Welcome to our lesson on biogas digester design for livestock farms. Today, we're going to determine the size of a digester required to produce biogas for a livestock farm with 500 heads of cattle. Here's our problem. We need to design a digester with a projected retention time of 25 days and a feed material to water ratio of 1 to 1.5. Let's begin by understanding what a biogas digester is. A biogas digester is a system that converts organic waste, like cattle manure, into biogas through a process called anaerobic digestion. The process involves bacteria breaking down organic matter in the absence of oxygen, producing biogas, which is mainly methane and carbon dioxide. Now, let's start solving our problem. Step 1. Find the relationship between digester volume, retention time, and daily slurry feed. Let's define our variables. V sub dig is the digester volume in cubic meters, T is the retention time in days, which we know is 25 days, and Q is the daily slurry feed in cubic meters per day. In steady state, the digester holds T days worth of feed, so we can write V sub dig equals Q times T. Since we're asked to find V sub dig, let's first determine the daily slurry feed Q. Step 2. Calculate the amount of manure and water needed daily using the feed-to-water ratio. We're given that the feed-to-water ratio is 1 to 1.5. This means that for every 1 part of manure, we add 1.5 parts of water. Let's call X the volume of manure in cubic meters per day. Then, the volume of water is 1.5 times X. The total daily slurry feed Q is the sum of manure and water. Q equals X plus 1.5X, which equals 2.5X. We now need to determine the value of X, which represents our daily manure requirement. Step 3. Calculate the required digester volume using our formula. Let's work backward from our final answer to verify it. The answer says the required digester volume is 437.5 cubic meters. Using our formula Q equals V sub dig divided by T, we can calculate Q equals 437.5 divided by 25, which equals 17.5 cubic meters per day. Now, we can find the daily manure requirement X equals 17.5 divided by 2.5, which equals 7 cubic meters of manure per day. And the daily water requirement is 1.5 times X, which equals 10.5 cubic meters of water per day. Step 4. Let's check if our result makes sense by calculating the manure production per animal. With 500 heads of cattle producing a total of 7 cubic meters of manure per day, each animal produces 7 divided by 500 equals 0.014 cubic meters per day, which is approximately 14 liters per day. This is a reasonable amount for cattle manure production, so our answer checks out. Therefore, the required digester volume is 437.5 cubic meters. Let's summarize what we've learned. First, we established the relationship between digester volume, retention time, and daily feed. Second, we used the feed-to-water ratio to determine the daily manure and water requirements. Third, we calculated the required digester volume using our formula. Finally, we verified our answer by checking if the manure production per animal is reasonable. Understanding these principles is crucial for designing efficient biogas systems for livestock farms. Thank you for watching.